Okay, how you guys doing? So, today we're going to be talking about linear systems of equations, and we're going to talk about how to solve them using substitution. So, as you might recall from our other ways of solving linear systems, we want to find the point of intersection of two lines represented by the equations in our system. So for this first one, our system, we have the equation y equals x plus 1, and we have 3x plus y equals 5. So we want to find the point x, y, where if we plug in these points to both of these equations, they still are true. So what we can do to substitute is we can take a look and we can see that we have something here that says y is equal to x plus 1. And so we can also see that down below in our second equation, we have this y here. So we can just plug in this first equation into our second equation. So you can see we can do 3x plus, and then this is where we're going to fill it in, equals 5. We're just copying down from here. And then we can plug in our first equation for y. So we can plug in x plus 1. So then from there, we can simplify, and we can say 3x plus x is 4x. And then we still have that 1, can't forget about it, and that equals to 5. So now we're just solving a linear equation. So then we're going to subtract 1 from both sides. Those will cancel. And then we're left with 4 here, and we bring this one down to equal 4x, and we know that those are equal. So then all we have to do is divide by 4 on both sides, and that tells us that x equals to 1. So we're not done yet. We need to plug in back our x into one of our equations so that we can find y. So it's really simple here because we already have that y equals x plus 1. So we know that y equals x, which here is just 1 plus 1, and that is 2. So y equals 2. So now our point xy will be 1, 2, and that's our answer. So go ahead and take a look at this next problem. It's very similar, and we're going to go ahead and try and solve it together. Go ahead and take a minute and think about how to solve it. Okay, so there's a number of ways you could do this. So you have here 2x plus 2, and then we make a little parentheses for our blank here. And we know that this here, y equals x minus 2, we can plug in that for our y here. And so that's why we have this 2 in front of these parentheses. So we're going to say y equals x minus 2. And we're going to plug this in. And now all we have to do is simplify. So we're going to do 2x plus, make sure you distribute out this 2 to both numbers. We're going to have plus 2x minus 4 equals to negative 4. And so then we know that these two terms can add together because they're like terms. So we get 4x minus 4 equals to negative 4. Then we can add 4 to both sides. These two will cancel because they're opposites. And then these two will also cancel because they're opposites. So we're left with 4x equals 0. So then we just need to divide by 4 on both sides, and we'll see that x equals to 0 because 0 divided by anything is 0. So now we need to do the same thing and plug back in our x into one of our equations to find y. So we can say that y equals to 0, which is x minus 2, and that's going to be equal to negative 2. So now we have our answer. Our point xy is the point 0, negative 2. Okay, so moving on to the next box. What if we don't have a variable by itself, right? In the previous ones, both of our y's were already by themselves. We had this y is all alone over here, and x plus 1 is over here. And this one, y is all alone over here, and x minus 2 is over here. But as you can see in our first example, neither of our variables are by themselves in either equation. So we have x plus y equals 2 and negative 3x plus 2y equals negative 1. Well, what do? In this case, we just need to get one variable by itself. So you can do this a couple of ways. I'm going to choose to get x by itself this time. So we can do x plus y equals 2, and then we can subtract y from both sides. And then plus y and minus y will cancel because they're opposites. So then you bring down this x, and that equals to 2 minus y. So now we have an equation where our variable is by itself. So we can use this, right? So now we can take it and plug in x into our second equation. So we can do negative 3, we'll leave a parentheses, and then plus 2y equals to negative 1. And then we can just fill this in right here for our parentheses. So we can put 2 minus y. So then we're going to simplify and get negative 6 plus 3y by distributing this negative 3 to both terms inside the parentheses, plus 2y equals to negative 1. Then we're going to see that negative 6 doesn't add up with anything. And then these 3y and 2y will add together to get 5y equals to negative 1. So then we can add 6 to both sides. And these will cancel because they're opposites. And we're left with 5y equals to positive 5. So all we need to do is divide by 5 on both sides. And that gives us y equals to 1. So that's great. And then just like the first two, we need to plug this back into one of our equations here to solve for x. So let's go ahead and plug it into x plus y equals 2. So x plus y, which is 1, equals to 2. So then we just subtract 1 from both sides, and these will cancel, and we get x equals to positive 1. So our point of intersection is 1, 1. That's our answer for the first one. So go ahead and use the same method in the second one to try and get one variable by itself from either equation and then solve for the point of intersection. Okay, all right, now we're coming back and we're gonna solve this together. So you can do this a number of ways, but the way I'm gonna do it is like this. So we're gonna take our 2x minus y equals to 1, and we're gonna add y to both sides. So these two will cancel because they're opposites, and we're gonna be left with 2x equals to 1 plus y. Then I can do two things. I can either divide by 2 to get x by itself, or I can subtract 1 from both sides to get y by itself. So I'm going to do that first. So we're going to subtract 1 from both sides. So then we're left with y equals to 2x minus 1. Okay, and now we have a variable all by itself, so we can go ahead and use substitution to plug it into the second equation. So we're going to plug it in here. So let's go ahead and write that out. We're going to have 4x plus 2 parentheses equals 11, and we know that our parentheses are going to have this right here, so they're going to have 2x minus 1. So we're going to go ahead and distribute this out and simplify, so we're going to get 4x plus 4x minus 2 by distributing this 2 to both terms in here, and that's going to equal to 11. So now we're going to have 8x minus 2 equals 11. And so then from there, we can see that by adding 2 to both sides, we will get 8x equals to 13. So then, dividing both sides by 8, we get that x equals 13 over 8. All right, it's a fraction, but don't be scared. That's our answer right there. So then, just like the other ones, we need to plug x back into one of these equations to find y. So we're going to do 2x minus y equals 1, and we know that x is 13 over 8, so we're going to do 2 times 13 over 8 minus y equals 1. So this is going to simplify to 13 over 4, because 2 over 8 is 1/4, and then minus y equals 1. So then we can go ahead and add y to both sides. 13 over 4 is going to give you y plus 1. Then we can subtract 1 from both sides, and we will get that y equals to 13 over 4 minus 1. And if we say that 1 is equal to 4 over 4, we can say 13 over 4 minus 4 over 4 is y. Okay, and so that's going to give us 9 over 4 equals y. So that's great. So now we have both of our points, and our point of intersection is going to be 13 over 8, 9 over 4.